right? Everybody good with that? All right, so now we're going to do more examples. So what we're going to do now is we're going to give various languages, and then we can build a number of things, right? We could build the DFA for it. We could build an NFA for it. We could build a regular expression for it. We can build an extended regular expression for it. We can build as many of those things as we can, right? Some of them might be easy to build. Some of them might be hard to build. Some of them might be so hard to build that we won't build them, right? We'll just say, oh, I don't know how to build that one, right? So here we're starting. Just to let you know, before I started PowerPoint, in fact, probably before I'd heard of PowerPoint, or maybe before there was PowerPoint, I taught this course once, and I had a bunch of notes. And those notes can be found online, and you can read them, but there's nothing in them that hasn't been cut out and put in the slides somewhere. All right, so this, in fact, what this is, you can see, it's a screenshot of my notes. All right? All right, so here, what do we want? We want, this is the empty set. Remember? So this accepts nothing. Right? So what is a regular, here's a DFA for it. What does it do? The empty string starts there, and then you keep reading. If it's a proper DFA, it needs a start state, and for every state you need a 0 edge coming out and a 1 edge coming out, right? We have all of that. What does this machine do? It's just always on that first state. It's remembering nothing, right? And in the end, it's not a double circle, right? So it's not an accept state. And what does it accept? Nothing, right? That's the guy. In fact, here's kind of a, remember I said, if you want to remember R bits of information, right? Suppose I want to remember 3 bits of information, then I need 2 to the R states, right? Well, here, 2 to the R equals 1. I only have 1 state, right? So what's R? R is 0 because I'm remembering 0 things, right? I'm always in that state. So what do I know because I'm in that state? Nothing, because I'm always in that state.
So it will never access.
Oh, no. How does a DFA work? You keep running until the string is over, and then when it's over, you say, is the state I'm in an accept state or a reject state? In this case, it's a reject state, so you reject the string. So you feed any finite string into this machine, and it will reject it, right? Right? Anybody want to give me a regular expression for this language? Remember, you could give any finite set as a regular expression. And that's certainly finite. It's empty, right? So that is a regular expression.
Is the set containing the empty set also a correct form of this definition?
We're going to do that next. That's a different language, right? So how are we going to build it? We actually have to, yeah? I don't think that's ever said anywhere. You need one of both. But if you want an accept state, I'll put one over here. It didn't say you could get there. All right, so here's another example. So this is a complement of what you were asking for, right? You were asking for, I want to say yes for the empty string, and I want to say no for everybody else, right? But this is the opposite. I want to say no for the empty string and yes for everybody else. So in some ways, there's one bit of information I need because I need to know, am I the empty string or not, right? Here, I know I'm in the empty string. Here, I know that I'm not the empty string. So that's one bit of information. And so how many states do I need? 2 to the 1, I need 2 states, right? if I was going to give these proper names, I would call this the name it. It's the empty string. And what do I call this one? Everybody but the empty string, right? And what does this machine do? It starts here, and if your string is the empty string, then it stops and rejects, right? But if there's more to it, then you read your first character, and then you busy wait on the rest until your string's over, and then you accept, right? Everybody buy that? Yeah? If it's the empty string? You mean an A? Well, then it's a different tape alphabet. And we're always assuming we know what our tape alphabet is. And because all my edges are leaving with zeros and ones, I'm going to assume my tape alphabet is 0, 1. Right? So if this was a DFA, then every state needs a 0 and a 1 leaving it if that's your alphabet. If your alphabet had an A, it would need an A leaving it. Right? If this was an NFA, then it's okay that there's not an A leaving it, but it's not going to accept anything with A's in it. Here, if it was an NFA, when you got an A, you would die, and so you would never accept anything. Right? Does that make sense? Everybody got this guy here? Now, let's think about, do I have it down here? What are regular expressions for it? Oh, here's a regular expression for it. So, sigma is, if you remember what sigma is, it's my tape alphabet. Right? So in this case, it's 0, 1. And and 0, 1 star is any string of zeros and ones. You can have 0 strings or 1 or 2 or 3 length. Right? So this says it needs to be of length at least 1. Right? I have 1 character followed by any string. Right? Does that make sense? All right, so here we want a mega has to begin with the 1, and it has to end with the 0. All right? So this is definitely on the test, right? This kind of thing. I mean, in fact, these examples are way easier than I've ever given on a test. But then people often get it wrong, so maybe I should make them easier. But actually, I take it back. This kind of question, I find most people, 2/3 of the class can build these things, right? There's a quarter of you, I'm afraid, will never be able to build one of these things. But we'll get 2/3, most of you to build these things. All right, so how are we building it? And again, I'm trying to have meaningful names, right? So what do? I have to begin with the 1 and end with the 0. So I start here, I'm calling it the empty string, right? So I start here, only the empty string is here. If I get a 0, I need to begin with the 1. So I'm in a dead state, and I'll cycle here, dead forever, right? This is the set. It begins with the 0, and I'm dead. Right? Does that make sense? If I get a 1, then I know it begins with the 1, and it ends with the 1. Right? And then if I come over, if I get a 0, well, it begins with a 1 and it ends with a 0. If I get another 0, it still begins with a 1 and ends with a 0. Right? But if I'm here and I get a 1, then I begin with a 1 and I end with a 1. Right? And if I get another 1, it still begins with a 1 and ends with a 1. Right? In fact, this should be reminding you kind of what we did last class. Right? Remember those proofs we did? I don't know if everybody signed up for the forum, because I sent out email to the forum saying that I looked over what I have posted from before, and there's an example going through what we did last class. Right? So what would the test questions be, right? Test questions be, given this, give me a DFA or an NFA, right? Here I got a DFA, right? And then give the things meaningful names, right? And then you want to prove by induction that these meaningful names are correct, right? So what we do is we assume by induction that the meaningful names are correct for all strings of length t or less, right? Now, give me a string. Now I consider some state, and I'm going to prove that this is a meaningful name for all strings of length t plus 1, right? Well, if the path comes to here, it either came from here and followed to 0. Well, if it came from here and followed to 0, then by induction, it came here and it started with a 1 and it ended with a 0, and then did a 0. So look at it began with a 0 and it ended with, it began with a 1 and ended with a 0, right? Or maybe it came from here and followed a 0. Well, if it came from here, it began with a 1 and it ended with a 1, but then it took a 0, so now we're over here. Right? People kind of see that's what we were doing in last class, was proving by induction that these names were right. Right? People buy that? Yeah? Could everybody do some discussion like this so far? When we come back after we're going to have a test. I don't know when. Everybody know when we have a test? Should we look? I don't remember when it is. 2nd of March? 3rd of February. Oh no, 2nd of March. He's so right. Look I should have believed you from the beginning. 2nd of March. And when is that? That's not for a long time. Right? When are we now? We're now in the middle of February, right? So 2 weeks. In fact, that's not so bad because it's 1 week of holidays and then 1 week and we got the test. All right. So anyway, everybody back here? So, in fact, that tells us something, right? We basically have 1 more week of lectures before our test, right? Because it's a week of holiday and a week of lectures, right? So what are we going to learn in those week of lectures? More of this kind of stuff. And so we can kind of guess what's going to be on the test, this kind of stuff. Yeah?
Most of the time the start state won't be the empty string.
No. No, not always. Here it is. Yeah?
Are you making it with drawing, or is it going to be like the drawing machines where you roll the stuff?
No, we're going to have drawings like this. In fact, it's going to be exactly like this. You're going to have a circle with meaningful names in it. Or maybe if the meaningful name's too big, you might say this is state A. And what does state A have a meaningful name? Right? And you're going to tell me which is the start state. You're going to tell me the transitions. And you're going to double circle the guys that are accept states. Right? That's what you have to. Yes, that's what you're going to have to do. Guaranteed, that's going to be on our next test, doing that. Right?
Why do we have the start as an empty string?
Well, because at some point I have to differentiate. At some point I have to say, what is my first, a big decision making is what is my first character, right? So, and when do I do that? I only do that when I'm in the empty string, right? So when I'm in the empty string, I have to know, right? And you note here I didn't accept this, right? This is not, because it doesn't begin with 1 and it doesn't, right? Oh, we didn't say, who are we accepting? Right, we're only accepting these guys. Right? Right? In fact, just off the top of my head, I can think about what questions I've had on tests. And I remember having a question, all strings where the first character and the last character are the same. Right? I mean, that's natural, right? So what do you have to do? You have to say, oh, it's a 1, and then you do this thing, and you accept these. Or if you start with a 0, you do the same pattern, except you remember these, right? So that was certainly on a test, right? Everybody got by that? And then you have a philosophical question. Does the empty string begin and end with the same character? right? And that's a philosophical question, which you could just, I probably told you. Because, yeah?
Why is there one path just returning from the accept state to the previous state?
From the accept, here? That right there? All right. Suppose you know that the string so far, you've read some string so far, and you're in this state. So if you're in your state, you can never look at what you've read so far, right? So here, I've read some things so far, and what do I know? Based on this state, I know that I begin with a 1, and I know I end with a 0, right? And then, what happens next? The next character comes, and it's a 1, right? So now what do I know? I know that I begin with a 1, and I end with a 1. So what do? I go over to this state. Right? Does that make sense? That was a very good question. If you didn't get that, that's very much like you got to ask that now or you're going to die. Right? Are people getting these things? Yeah?
So we're designing a DFA for every situation. So if we were to get a 1 at the end, we go back.
Yeah.
But that would tell us that would be rejected, right?
What?
If we end with a 1. And the reason when we have the beginning with 1 ends with, that means every string that ends with a 0 is accepted.
Yeah.
So we're designing with every possible thing as well, right?
What we want is any string that's in the language, meaning it begins with a 1 and it ends with a 0, has to be accepted by this machine. So if you took that string, any string that begins with a 1 and ends with a 0, has to land in an accept state.
That's why when it starts with a 0, it just dies. It just goes down there.
And on the other hand, you need to build it so that any string that's not in the language is rejected. Right? So how do you prove that? Right? The one way, we gave 2 proofs last class, right? The second proof, which says, well, if it's in the string, if it's in the language, it has this property, and hence I can give you a path, right? And the other side, you could say, well, if it has a path, then it must have this property, right? You could do that. Or you could do the induction method, right? The induction method is you give meaningful names for each state, and then for each state you prove, well, if the string's of length t plus 1, then I know if it's of length t, right? And you do that kind of induction. So you should be able to somehow think about both of those, right? In fact, the question could well just be, here is a language, give me a DFA or an NFA, and argue to me that your machine does the language. Argue it to me somehow, right? And how would you argue? First off, you want to make sure that your argument goes in both directions. You want to say if it's in the language, you have to some argument that there's a path. And you have to argue if there's not a language, it's not in the language, then there's not a path. Which it's easier to say if there is a path, then it is in the language. Right? Everybody got that? Right here, let me say that again because maybe you missed it. Right? You want to say if alpha is in the language, then it's accepted by the machine, right? And if it's a DFA, then there's one path to an accept state. And if it's NFA, there could be many paths, but one of the paths is good, right? But the other thing you have to prove, if it's not in the language, then it's not accepted by the machine, right? There's not a path. And this is kind of hard to do, right? So instead, we say, if there is a path, then it's in the language. Right? Did I do something wrong? right? It's sort of both directions. Here you say if it's in the language, then there's a path. And if there's a path, then it's in the language. Right? Everybody see that? You need to do both directions. And how do you do it? Well, you could do it by saying if it's in the language, then it has some property that it begins with a 0 and ends with a 1, and hence I can construct a path. I can show you how it gets to the accept state. Right? And the other way you could say, well, suppose that there's a path. Well, the paths have to have this sort of form, and hence I can show that it's in the language. Right? Like, for example, in this case, if there's a path, if it accepts, right, then there's got to be a path from here to here. Right? And I'll tell you, any path that goes from 0 to 0 has to begin with a 1, and it has to end with a 0. Right? So this kind of proof, it's easy to prove this one. Right? Yeah?
It seems to me like it actually can end with a 1. Because if we just, it says it begins and then ends 1. Doesn't that mean you can just end it before even reaching the state of the where you put the 0?
If you get all 1s?
Yeah, you just
Yeah, but this is a reject state, you know. You know, this is double circle. So if you end here, it's a no. Right? This is the double circle. So if you end, yeah, when I say there's a path, it has to be a path to here. Right? And I'm claiming any path that goes to here. Would you agree that any path that goes to here has to end in a 0?
Yeah. I'm just a little bit. I just don't understand why it says ends 1. Like there's just the part that completes the circle.
Here?
Yeah.
Any string, would you agree that any string that gets here ends in a 1? And begins in a 1. Right? So this is a meaningful name. All strings that get here begin with a 1 and end with a 1. That's the definition. That's my name for the set. It's the L prime for the set. It's the set of strings that have passed to that state. Right? So if you want to prove it by constructing paths and using paths, then that would be pretty easy. Right? In fact, well, it has a cycle, but I mean, it's still pretty easy. Now, if you want to prove it by induction, right, everybody could do that. That's pretty easy too. Well, in my opinion, it's pretty easy. Right? In my opinion. Well, if I have a string, when does it get here? Well, if it's in length t plus 1, then the string of length t was either here and I got a 0, which I'm good, or it was here and I got a 0, which I'm good. Right? That proves me everything of length t plus 1 that gets here is good. Right? If and only if. Everybody kind of buy that? Yeah? The start, this one here? Oh, start, what is it? Oh, again, we want to give every state a meaningful name. And the name is, what are the strings that can get there? What strings can get there? Only the empty string. Right? If you're in that state, what do you know? You know that you haven't seen anything. Because as soon as you see something, you leave. Right? Yeah?
Can you continue with the question about whether the empty string is begin and end with the same continuous?
Oh, here, it definitely doesn't begin with a 1 and end with a 0, so we're not including it. Yeah. Yeah, begin and end. I don't know. It doesn't begin and end with any character. So it begins and ends with the same non-ending and beginning, right? So I could argue that it doesn't begin and end with a different character, right? So does it begin and end with the same character? I don't know. That's why I said it was a philosophical question, right? I think on the test, I mean, I would have told you because I knew it was a philosophical question, right? And I think I would say it does begin and end with the same character. And the reason I would say that is because I feel more strongly that it doesn't end with different characters, right? But you could do whatever you wanted. In fact, it would have, the DFA would look like this and like this, and the only choice is, do you circle this or do you not circle this, right? It's not a big issue. Yeah? Could you try? I didn't get any of that.
Do you have memory?
Yeah, can I say like x equals the first character or something?
Oh.
In one of the meaningful names.
Yes. Well, X. Yeah, you could if X meant something. Yeah. In fact, one of the things what we could do is I could, another representation is I could give you code, right? That has a little loop, and each time it goes around, it reads the next character, and then what state it is in depends on the values of certain variables. And so I could well say the value of X here is, in fact, the example, remember we had L was the length of the string so far, and R was whether it's even or odd, right? So the state I'm in says, well, R is even, and L is the length of 0 so far. So you could certainly, right? But there'll be extra meaning there, right? The extra I mean, in some ways you can do it without the variables because R does mean whether the number of ones is even or odd. So I would probably not mention R. I would say the number of ones so far is even, right?
Or like I was trying to think of the other problems earlier. Like would you need to say store the first character inside of something, or can I just say that like the next state has the character?
My feeling is you're making it harder than it is. See if it comes up again, because I think that doesn't really come up here.